Okay, let's dive right into this. We are looking at a truly monumental shift in the world of research today. Seriously, this is a moment where artificial intelligence just flat out cracked a foundational biological mystery: how proteins fold. Now, for the students and future scientists tuning in to this expert analysis of the latest research, you've got to understand this is probably one of the most vital turning points in modern science. We're talking about a barrier that has literally stood like a brick wall in front of researchers for over half a century. You see, proteins are the building blocks of life. They're responsible for practically every function in our bodies. But here's the catch. To understand what a protein actually does, you have to understand its incredibly complex three-dimensional shape. And for 50 years, predicting that exact shape from just a simple sequence of amino acids was basically considered the holy grail of biology. It was a problem so vast, so mathematically daunting, it seemed completely unsolvable.
So, what happens when scientists are just completely stumped for decades? Imagine trying to predict the exact shape a piece of crumpled paper will take before you even crumple it. Sounds crazy, right? Now imagine doing that on a microscopic scale, with literally astronomical possibilities. This right here brings us to the fundamental difficulties of working with complex biological systems. Scientists actually call this Leventhal's paradox. It basically says that a single protein could fold in so many different ways that it would take longer than the age of the universe to try every combination randomly. No way, right? You got the absolute brightest minds, the best labs on the planet, and yet this complex chaos brings progress to a total grinding halt. This inability to quickly decipher these structures created a massive bottleneck in research. It meant putting countless potential medical discoveries and life-saving treatments on hold, just because this foundational puzzle was an unyielding mystery.
Let's move to Section 1 and see how this builds: science versus the uncrackable problem.
Looking back, this major biological problem was first identified decades ago. And for generations, scientists had to rely on this grueling, painstaking trial-and-error approach in the lab just to fight back against the scientific chaos. Mapping just one single protein structure using traditional techniques, things like X-ray crystallography or cryo-electron microscopy, could easily take a PhD student years of continuous, exhausting work. It was a manual, deeply physical battle against biological complexity, and it often cost hundreds of thousands of dollars for just one structure. But today, AI has fundamentally solved the puzzle. It's generating highly accurate structural predictions in a fraction of the time. We've literally gone from years of blind trial and error to getting precise answers in mere minutes. It's wild. The sheer weight of time spent in the dark, entire careers dedicated to uncovering just a handful of structures, is exactly what makes this sudden illumination so profoundly inspiring.
Now, what's really interesting about this is the sheer stubbornness of the roadblock. Scientists couldn't crack this for decades. And we aren't just talking about a minor speed bump. We're talking about inherent human limitations when you're faced with virtually infinite variables. Human minds, as brilliant and dedicated as they are, just inherently struggle to manually process the sheer mathematical chaos of these microscopic structures. When you're dealing with systems this complex, the data points are just overwhelming. Researchers were essentially trying to find a needle in a multi-dimensional haystack. This whole history of the struggle against scientific chaos really shows just how difficult it is to model biological realities with the right computational tools. You know, it was never a lack of human ingenuity or effort. It was simply that the biological mechanisms were operating on a scale of complexity that our traditional computation and observational methods were just never equipped to handle.
All right, let's jump into Section 2, the AI breakthrough. This is where things get incredibly exciting. So, on one side, you have deeply dedicated human scientists struggling against biological complexity for decades, and on the other, artificial intelligence fundamentally shifting the entire paradigm. But why exactly does AI solve complex problems like this so effectively? Well, the secret lies in the very essence of neural networks and how they learn. These algorithms are specifically designed to conquer chaos. Instead of trying to calculate every single physical law and atomic interaction from scratch, which is what we used to do, neural networks learn incredibly fast by training on massive databases of known protein sequences. They analyze hundreds of thousands of previously solved structures, and they recognize these incredibly subtle, hidden patterns in the data that humans just literally cannot see. By leveraging these vast informational networks, the algorithm cuts right through the chaos. It learns the rules of folding implicitly and predicts completely new structures with pinpoint accuracy. It is a real game changer.
So, the crucial point is exactly this. AI just solved the problem scientists couldn't crack for decades, and the global scientific community was essentially left speechless. But the true significance of this breakthrough? It isn't just about winning some biological game of chess.
is about how this technology actively saves human lives. Think about it. By instantly generating highly accurate models of almost every known protein, this AI provides the exact blueprint we need to develop new, life-saving drugs faster than ever before. We can now actually understand how diseases function at a molecular level and design targeted treatments with unprecedented speed. From creating new antibiotics to tackling really complex genetic diseases, algorithms have fundamentally defeated the chaos of structural biology. It accelerates the entire timeline from discovery to treatment, meaning therapies can reach patients years earlier than they ever would have using traditional methods.
Moving right along to Section 3, the future of discovery.
And this brilliantly illustrates our key takeaways from this incredible milestone. First, decoding these complex structural biological systems was a major scientific hurdle that existed for over 50 years. Second, the sheer chaos and mathematical complexity of the problem were simply beyond traditional human computation and manual laboratory methods. We just couldn't crack it. And finally, AI neural networks provided the definitive solution by successfully identifying the hidden patterns within that biological data. Look, this isn't just a win for computer science. It unlocks a completely new era of medical research. The real essence of this victory is that we now have a tool that transforms an unsolvable mystery into a standard, accessible database. It is forever changing the way we approach biological science.
So, this leaves us with a pretty massive thought to wrap up this explainer. If AI can solve a decades-old problem today, what impossible mystery will it solve tomorrow? For the students and future scientists watching, this is the ultimate question. We are standing right at the edge of a completely new frontier of AI-assisted discovery. The future of medicine has fundamentally changed. The major tasks for your generation, they won't be spent in the dark, wrestling with basic structural roadblocks. Instead, your challenges are going to involve taking these AI-generated blueprints and building upon them to cure diseases, engineer sustainable enzymes, and tackle huge global issues. The tools to decode reality are now literally in your hands. Thank you so much for joining me to explore this historic milestone. Keep that curiosity alive, because your role in this new era of discovery has absolutely never been more thrilling.